ओए गधा क्या कर रहा है? पढ़ाई कर, खाली झूठ नॉलेज।
Okay, so today we'll discuss about the file handling in Python. You must have read about the file handling in C language or the C++, maybe in some other language, maybe Java. So many of the programming languages, they provide a facility of file handling. They provide the facility of file handling. Similarly, in Python also provides the file handling functionality. So we can store data permanently on the on your disk. Now, question is that why should you go for file handling, right? Anybody who can say that what is the need of file handling?
So to store the data permanently.
To store permanently. Suppose the program that you are writing on your system, are those programs are stored permanently or temporary?
So temporarily. Whenever the program ends, all the memories are released.
Now, the program that you are writing, is it permanent or temporary?
The program is permanent.
Program is permanent. Only the data are temporary. If I say I have written a program of some 30 line, 300 line program, the program we have stored in the disk, that is permanent. However, suppose in the program I am inputting some value, I am doing some calculation, displaying those on the monitor. All those things are temporary in nature because it is in the primary memory. We do it in the primary memory, and you know that primary memory is volatile in nature, temporary in nature. So as long as the power is there, the data is there. Once the power gone, the data lost. And that is the reason for which we want to have file handling, where we want to store those data permanently on your system. So although the file itself, the program that you are writing itself is being stored on a disk, however, the data that we input, the computation that you do, those are not being inputted, those are not being saved permanently on your system. So how to store those data permanently on a system? And second part is that how to retrieve those data so that we can do operation later. Today we have stored some data. The next day I will come, I want to retrieve those data so that I will do some modification, I will do some searching, I will do some insertion, deletion, those operations. Okay, so that is the reason for which the file handling is required. Just look over here. What we will read over here, we will read about the text file versus binary file. We'll read about the text file, we'll read about the binary file, read and write operations, random file operations, reading, writing the CSV files, and some PKIL module. These things we'll discuss in our file handling. So I was discussing about what is the need of file, right? So it says, when we interact with the computer, suppose file handling we are not using, right? So we input data to the memory. So we input data to the memory through what? Through the keyboard, right? We input data to the memory through keyboard, and whenever required, we can display those data through this monitor. So we bring the data from the memory and display it on the monitor. Is it understood what I'm saying? We input data from the keyboard, it goes to the memory. We do some operation in the memory itself. Memory means it is RAM, random access memory. So we store it in the RAM or main memory, and whenever I want to display those monitor through this video, correct? The keyboard and video, the basic input output devices are called the console of the system, are called the console. So till now, whatever the program we have done, it is between the interaction between the console and memory, console and RAM. So we input data to the RAM, it will be stored in the RAM or main memory. And whenever required, we retrieve the data from the main memory and display it on the console. Main memory is volatile in nature, that you already know. Correct? So our interaction, whatever we are doing, this is between these two only. So we say console memory interaction. This part is actually console memory interaction. Which part? The console and the RAM. So till now, whatever the program we have done, it is between console and memory. But we want to store these data permanently. Means whatever data we are inputting, those data also I want to store it permanently. To store those data permanently, we need to send those to the disk. Correct? So this is the disk on which different kinds of files are there. So what you have, you need to store those data to the file. What kind of file will store? We can store text file, image file, video file, graphics files, animation files, different kinds, nature of files can be sent to the disk. So disk contains different kind of files over here. Correct? So now question is that how to send those data from the memory to the disk? From the memory to the disk, first part. Second, whenever required, I want to bring it from the disk to memory. The first part is that I want to send the data from the memory to the disk. Different types of files, data that I want to send from the memory to the disk. And second part is I want to read those data from the disk to memory, and later I'll send it to the console for display. Are you getting me what I'm saying? Is it understood, the second part what I said?
Yes, sir.
So we send
Sir,
data,
one more time, sir.
we will. So what we are saying till now we have done from console and memory. We send data to the memory, from memory we read. So these two are only there. Now what we are going to do, we want to send from memory to disk and disk to memory. We'll send some information to the disk, and whenever required, we'll bring those data to the memory. We'll do some operation over here. Correct? Suppose I'll say I have to input the marks of 10 students and find the total. So that program we have done over here and we are running it. So 5 student mark and total is in the memory. Once the program is off, the data is lost and the total mark is being lost. What I want to store those data and the total mark onto the disk. So I can write those, I will send it to the disk. And again, I want those data to be read, and I want to do some other operations. I want to print those data or something. So I'll bring it to the memory, and from memory, I know that how to display it on the monitor, because this part already I know. Print statement, input statement, these are being used. So I will send it to the console. So disk to memory, memory to console. Correct? So we'll send from console to memory and memory to disk. So as we have already read about the console and memory interaction, print, input, these things we have already read, from memory to disk and from disk to memory. This part is called as the file handling. So file handling is nothing but sending the data from the memory to the disk, and whenever required, this part is known as the file handling or memory disk interaction. Correct? So what do you mean by a file? That a computer treats as a single unit. So what is file? File is nothing but it is a collection of different. So is a related data that a computer treats as a single unit. Why is a single unit? When you want to access if the content of a file, the file has to be, entire file has to be accessed fast. So this has a common name. One name is given to those data that are being stored in a file. Computers store files to secondary storage so that the content of the files remain intact when a computer shuts down. So whenever, even if a computer shuts down, the data that are being stored in secondary storage device will be, the data will be intact. Those data will not be lost. Correct? So data in the primary memory are lost, but the data in the secondary memory are intact. They do not lost even if the power loss. So when a computer reads a file, it copies the file from the storage device to memory. Try to understand. When it reads a file, suppose I want to read a file. Read a file means I want to transfer the data from disk to the memory. Correct? I want to display it. To display it, I have to bring from memory to console, memory to video. So reads a file means it copies the file from the storage device to memory. When it writes to a file, it transfers data from memory to its storage device. I have told you in the previous slide that reading means reading from the disk to the memory. Writing means writing from the memory to the disk. Do remember? Read means read from the disk. Read from the disk. Write means write into the disk. So always disk will be taken as the source or target. Read means disk, read from the disk. Write means write into disk. Correct? Here what you have? The reverse one. Right? We write it over here, we read from here. Is it understood? Read and write operation on files. Is it understood or not?
Understood, sir.
Okay.
Yes, sir.
Okay. So another concept we use in file handling is a buffer, right? What is this buffer, sir? A buffer is a special work area that holds data as a computer transfers them to or from the memory. Buffer is what? It is a what? Do we have the computer architecture or operating system you have read earlier? Have you read the computer architecture organization or something, that paper?
Yes, sir.
Yes,
Sir.
sir.
Okay, do you know about the buffer? Okay, I'm explaining it again. Buffer is something like a temporary area. Like, suppose I say you want to watering your plants at your home. At your home, you want to water the plants. So you have a bucket, and what you do, you fill the bucket from a tap, then go on watering the plants, come back and again fill the bucket to water the rest of the plants. So what your time is waste because for filling the bucket every time. If you would have another bucket over there, we call as a buffer kind of thing. So while you are watering the plants, at the same time, the another bucket can be put on under the tap to fill. So buffer is that kind of thing. So whenever we want to read some data, the read-write speed is not always same for all the devices. Suppose I want to send the data from keyboard to memory. So sending data from the keyboard and writing in the memory, the speed is not same. So different components of the computer has different speed. The slowest device on your machine is which one? The slowest device on your machine is keyboard. From all the input output devices, keyboard is the slowest device. Just think of if I'm sending some data from keyboard to some other other component, then keyboard is the very slow device. I'm sending, suppose processor is sending some data to the video. Processor works with a very high speed, and video might be writing at a very low speed. So how it will be managed? It says that it will be kept in a buffer, and from buffer it will go to the output device. You give a print statement to print on a printer. Once you give a print statement, that goes to the print buffer, and from print buffer it will go for printing. Similarly, when you give read or write command, the content is read to a buffer, and from buffer it goes to the target. Correct? So a buffer is a special work area that holds data as the computer transfers them to or from the memory, either from the memory or to the memory if you transfer the data. So we'll have a buffer over there. We introduce a buffer over there. That means in this diagram, either you write into this memory or you read from this memory. So you can have a buffer over here. You can have a buffer over here. Similarly, we can have a buffer over here. Understood? So doing any operation with memory, either a read or write operation, the data goes through a buffer. Buffer is nothing but a temporary memory location. Some space is being reserved for the same. Correct? So it is a special work area that holds data as the computer transfers them to or from the memory. the physical requirement of the devices can deliver more data or for input than a program can use at any one time. So what is physical requirement? Means actual requirement. The physical requirement of the devices can deliver more data for input than a program can use. Suppose a program can use 10 bytes of data, but it is giving 100 bytes of data at a time. So what it will do? It will store in a buffer. The buffer handles the overflow data until a program can use it. So those data which are being produced will be stored in a buffer. So moreover, the buffer also holds data until it is efficient to write the data to the storage device for output. So what it does, the buffer also holds the data until it is efficient to write the data to the storage device for output. It's not for read also. If you are going for any write operation, then also the data is being stored over there in this buffer before writing to the disk. So if you want to read from data from the disk, read from the disk, send it to buffer, buffer to memory. Similarly, if I want to transfer something to disk, memory to buffer, buffer to disk. I hope it is understood, buffer. Okay. Now we'll go for text files and binary files. Basically, we dealt with two different kinds of files. One is the text file, another is the binary file. Text file are ASCII files. Text files are ASCII, text files are codes. What is ASCII text files? ASCII codes is, we already know, American standard for information interchanging. What is that? This is a universal accepted. That means if you have written something in using ASCII code, that can be opened by using any of the editor. You go for any operating system, any of the editor, that can be opened because it has the common code. Something you have written in Notepad or something you have written in, in ASCII format, in your VI editor or something like that. That content can be opened by any of the editor you take for any operating system. But if I say, if you have something you have written in MS Word, can you open it in any other editor? You need the MS Word to be there or compatible across there. If you have some file, a video file is there, the video file has to be opened with a video software. Correct? If you have audio file, has to open with the corresponding audio software. But this text file can be opened by using any of the text editor, any of the text editor you take. Correct? So basically, we can deal with both text file and binary files in Python. Right? It is unlike, this is like any other programming languages like C and Java or C++, we have text file and binary files. Here also we can have text files and binary files. Besides that, we can also work with image file, all those files. This comes under your binary files. Image file, I can read an image file, I can read a video file, the different other files can be read. So text file consists of sequential characters divided into lines. So you have a sequential characters are there and some characters in a line. Each line terminates with a new line character. So after every line, there is a slash. These are text files. But the binary file is that the binary file consists of data values such as integer, floats, complex data types using their memory representation. I will give you the detailed difference between this binary file and text file. That also usually comes as a question, the two different between binary file and text file. Do remember in binary file, in text file, everything is in form of text. You write 45.76. It will be considered as text. 4 as a character, 5 as a character, dot as a character, 7 as a character, and 6 as a character. So you write 45.76, but this entire, each one is one character. What is in a binary file? 45.76 when you write, this 45.76 is a float value. This should be considered as a float value. So each one is not one character. Correct? So anyway, we'll go for give you the detailed difference between this text file and the binary file. So what's the difference between text mode and binary mode, and which mode to use? Correct? We have two modes over here. One is text mode, another is binary mode. We have read about the text file and binary file. So which one to use at what time? So we have to first differentiate between these two, text mode and binary mode. So we have to analyze with three factors over here. So we can say these are three differences between text mode and binary mode. First thing is that how the new line character is being represented, or how new line character is stored over here. How /n or new line is stored in text mode, how the /n is stored is there in binary mode. This is first difference. Second difference, how the end of file is indicated in text mode and how the end of file is indicated in the binary mode. The third one is that how numbers are stored in the file. Both in text file, how the numbers are stored, and in binary file, how the numbers are stored. So this will differentiate the text mode to the binary mode. The first factor for what? Differentiating the text with the binary mode. The first factor is what we have discussed. First factor is how the new lines are stored. Here it says in text mode, a new line character is converted into the carriage return line fed combination, these two combinations. The carriage return line fed combinations. Carriage return line fed combination. So two characters are combined over here. In text mode, what happens? A new line character is which one? New line is /n actually. New line is which one? /n. So the new line character /n is converted into two, carriage return and line fed. What is carriage return? Carriage return is this one. Carriage return is /r and line fed is /n. So when you type new line is actually combination of these two. What /r does? /r moves the cursor to the beginning of the line without advancing to the next line. So it will just bring the cursor to the beginning of the line. So it is not taking to the next line. But what /n is doing? It moves the cursor down to the next line without returning to the beginning of the line. /n, what it does, it takes to the next line, but it doesn't move the cursor to the beginning of the line. But you must have marked that when you press enter, what it does, it goes to the next line, but to the beginning. Is it or not? So when you press the /n, or enter key, what it does, it brings your cursor to the beginning of the next line. That means the /n and /r both are working. So in text mode, when you press a enter key, the new line is actually converted to both /n and /r. So whenever you write onto the disk, this /n, the enter key is being converted to /r and /n, and it is written into the disk. And similarly, when you read from the disk, whenever a line is read, that is being converted to /r and /n. Correct? So it says that in text mode, a new line character is converted into the carriage return line fed combination before being written to the disk. Likewise, the carriage return line fed combination on the disk is converted back into new line when the file is read by Python program. Correct? So that conversion takes place. But if you look into the binary mode, this conversion doesn't take place. If a file is opened in binary mode, as opposed to the text mode, these conversions do not take place. These conversions do not take place. Correct? So what it does, every character has a ASCII value. So if you are pressing /n, that ASCII value is inserted in the file in the binary mode. So no conversion takes place. So in binary mode, each end of line is signified by a carriage return line for combination and is counted as 2 characters in binary mode. So in binary mode, it is not /n only, it will be considered as /r and /n. So 2 ASCII values will be inserted. Correct. So the end of line is actually the end of line, the enter key that you give for end of line. The end of line, look here, the end of line is actually 2 ASCII characters, is a combination of /r and /n. It is a combination of /r and /n. Is the first difference understood? Everyone?
No, sir.
Not understood?
No, sir.
Okay. Just to see over here, suppose I am.
So please explain the text mode once again.
Let me tell you. Where is my? Just think that I have this file. I have written a file in text mode. So whenever I am writing into this file, suppose the first line is written, I press a enter key. And I write the next line, I press enter key. 3-4 lines I have written. So how many enter key I have pressed? I have 4 enter key I have pressed. So in the text mode, so this is, we have written in what? We have written in the memory. We want to transfer it to what? We want to transfer it to the disk. We want to transfer it to the disk. While transferring each of these, whatever I have written, each of these will be transferred to this file as a text. That means if I write 4, 5, it will be considered as 4 as a character, as 5 as a character. So it will be transferred character by character. And after the first line, I have pressed the enter key. This is after the first line is, but this is actually what? This is the end of line actually, the end of line. This end of line is a combination of 2 characters. That means when you press enter, 2 characters are there, /r and /n. So it is automatically, so whenever you are writing to this file, this is also written in first line. The next one will be written in second line because this /r and /n conversion will occur. So this will be written in 4 different lines. However, if I write the same in binary mode, I want to write in a binary file. This to the disk, but I want to write in, this is what? This is the text mode. But if I want to write in a binary mode, what will happen? The first line will be written. This is not that character will each one will be converted into text. No. If it is an integer, integer will be converted to integer, float will be converted to float. Or so the conversion will take place. Accordingly, it will go to memory. Now the last line that you have pressed enter, this has 2 characters, /r and /n. So after writing all this, this is /r ASCII character, /n ASCII character, then the next line character conversion, then /r, then /n. Like that, it will be stored in the binary file. So /r ASCII character, /n ASCII character will be there. But here what it does, instead of /r and /n ASCII character to be placed, these 2 will be converted to new line and it will come to this line in the beginning of the second line. So automatically it will be written, the next character will be written in the next line. Is it understood?
Yes, sir.
Okay. This is the first, that was the first difference. Now coming to the second factor. What is the difference between ASCII and text file? In text mode, a special character end of file whose ASCII value is 26 is inserted after the last character in the file to mark the end of file. If you could have remembered in a text file, suppose in your MS-DOS, after creating a file, you press Ctrl Z to save it. In your Linux also, when you are cat greater than file name, while you create a file, the Ctrl Z, this is nothing but the end of file marker. The end of file marker is actually that one, whose ASCII value is 26, correct? So in text mode, what happens? After writing this, the ASCII value of this is inserted. A special character end of file whose ASCII value is 26 is inserted after the last character of the file. After writing all the contents, this is automatically inserted. Why it is inserted? To mark that this is the end of file. So once the end of file marker is encountered, now it will not stop reading over there. It will not read the content afterward. And who inserted? The automatically the compiler automatically inserted. So you do not have to do anything. This is whenever operating system inserted over there, not compiler, operating. So when you type the content, press Ctrl Z, automatically this end of file is added to the end of the file. However, there is no such special character present in the binary mode to mark the end of file. So end of file marker is there in text file, but end of file marker is not there in the binary file. Now I will say that if end of file marker is not there in the binary file, if a file is created in binary mode, how to detect the end of file? It says that the binary mode files keep track of the end of file from the number of characters present in the directory entry of the file. So whenever a file is created, how much byte the file has taken, it is being already there, the information is already there. So in binary mode, it takes those information, it uses those information to detect the end of file. Suppose my file is 100 bytes, so the binary file will know that maximum 100 bytes I have to read from this file. This file contains 100 bytes, so I can move 100 bytes from the start to the end. So end of file marker is not required in the binary mode. End of file marker is not required in the binary, whereas end of file marker is automatically being inserted at the end of the file in the text mode. I hope it is understood. Is it understood or not?
Yes, sir.
Okay. So that another factor, the difference between binary mode and text mode is that in text, the numbers are stored as a string of characters such that this 1, 2, 3, 4. Suppose I will say I am storing this value I want to store in text mode. So each one will be considered as one character. So 1 as a character, 2 as a character, 3 as a character, 4 as a character, and 5 as a character. So this will take 5 bytes. So 1 byte per character it takes. So similarly, if I want to store 1, 2, 3, 4.56, how much byte it will take? 1, 2, 3, 4.56. So 1 as a character, 2 as a character, 3 as a character, 4 as a character. The dot symbol is also a character. 5 and 6 are characters. So 4 plus 2, 6 plus 1, 7 bytes it will take on the disk. But if you go to the binary mode, 1, 2, 3, 4.56 is nothing but, it is what? It is a 1, 2, 3, 4, it's a float. So it is a float, means how much byte it will take? Maybe 4 bytes. It depends on the system architecture, but it's a 4 bytes, right? So this will take 4 bytes. This will take 4 bytes on the disk. Correct? So 1234.56 occupies only 4 bytes on the disk in binary mode. In binary mode, the numbers are stored in the same way as they are stored in RAM. So that the number 1, 2, 3, 4, 5 occupies 2 bytes, assuming that integer takes 2 bytes. So this is an integer. This is an integer. So it will assuming that 2 bytes, so it will take 2 bytes over here. And this is float, this will take up 4 bytes over here. Correct? So the way it is being occupied, in the way it is being represented in the memory, it is exactly same way it will be written to the disk. In which mode? In the binary mode. In text mode, whatever the way you are represented in memory, it will be converted to text and it will be written to the disk. These are the 3 differences between text mode and binary mode. So we can open a file either in text mode or in binary mode. I hope it is understood. Is it understood or not?
Yes, sir.
Yes.
Yes, sir.
Okay. So what are the basic operations performed on a data file? What are the basic operations performed on a data file? We'll have to name a file. We have to give a name to a file by creating it. We can open a file. If the file is already created, we may open the file. We may want to read the content of the file and bring it to the memory, and subsequently from the memory we may print it on the console. And writing data to the file means we want to send the data from memory to disk. So we may send from console to memory and memory to disk. Correct? Reading data from the file means we want to send it from what? Disk. Reading data means what? We can say reading data from the reading data means from which? What is the source? What is the destination?
Sir, source to program file. Means disk to program file.
Disk to disk to memory.
Yes, sir. Memory.
Disk to memory. And if I want to display it, then I have to send it to the console. Writing to the disk means I may send it the data from console to memory, and from memory I may want to write it into the disk. And do remember, in all these operations, I may have a buffer over here. I may have a buffer over here. So because for all reading and writing operations, I may require some buffer before and after these memory operations. I said already, correct? So naming a file, opening a file, reading data from the file, writing data from the file, and after doing all my operation, I want to close the file. So these operations, if I know, that means the file handling things that I can do. Now, how to open a file? For opening a file, the syntax is open the file name, the access mode. Just a second. Hello. So to open a file, what is that? File object. File object. Open is the function. I'll tell about this R in the next slide. Then we have file name. So open file name, access mode. Access mode means for reading, writing, for what purpose you want to open the file. I want to read the file, I want to write into the file. So what purpose you want to add at the last, which operation I want to do is the access mode. This is the file name, right? R I will tell you in the next slide only, right? So open, file name, access mode. And if the file is present in some other location, we have to give the entire path. If it is in my pen drive, then I will write E:/this or F:/this I will write. If it is in the entire path, I have to give. And whenever a file is opened, a file handler is associated with it, so that in every operation we do, it will be done through the file handler. So file handler is like a cursor which defines from where the data has to be read or written into the file. So the file handler is like a cursor. No, cursor, what it does when you move it on your screen, it from the area it will be selected. Similarly, file handler like a cursor which defines from where the data has to be read or written. So you will use the file handler to read or write the data on the file. Correct? And what are these access modes? Access modes governs the type of operation possible in the open file. What are the different kinds of, whether read, write, append, what kind of other operations that can be possible in the file. Correct? The file should exist in the same directory as the Python script. Otherwise, full address of the file should be written. So file name, whatever, as I said, file name you may give any file name, doesn't matter. But if it is present the current directory, you may not write anything. But if it is in some other location, you have to write the entire path of full address of the has to be written. I'll give the example for the same. And I said this R also I will explain. So among this, let us talk about this access mode. We'll see that what are the different access modes are over here. There are different access modes, file opening, or we say the file opening modes. R, W, A, R plus, W plus, A plus. R is for reading. If you write R in the access mode, that means it is only for reading. We cannot write any data into the file. So R is open a text file for reading. The handler is positioned at the beginning of the file. If the file doesn't exist, it registers an IO error. This is also the default mode in which the file is opened. If you do not specify any mode, it will be default, it will take as read. Correct? So once the file is open in read mode, it is only for reading. We cannot update any operation. We cannot do any update operation. And the find handler will be at the beginning of the file. The handler is positioned at the beginning of the file. And if the file doesn't exist, it gives an error. The W file opening mode says that the file can be opened for writing. The file W mode says that for writing. Writing means writing new content. If the previous content is there and you open in W mode, all my previous content will be lost. Suppose I have a student data, student file where 100 student or 1000 student informations are there, but I open again in W mode. I want to write some information and open in W mode. All my previous data will be lost, and whatever I will write now, the new content will be written over there. Here the handler is positioned at the beginning of the file, and it creates a file. If the file doesn't exist, it will create a new file. Is it understood? R and W mode?
Understood, sir.
Okay. So another mode is A mode. A mode says that we can add the content at the end of the file. We cannot add the content anywhere in the file, only at the end of the file. Right? Append, we say, A for append. So it is a file for writing, but the file is created. If it doesn't exist, the handler is positioned at the end of the file. The data being written will be inserted at the end only, after the existing data. Only at the end of the file we can go on adding. So 100 data will be preserved and new data will be written at the end of the file. In R plus, what we can do? This is both for reading and writing. We can do read operation and write operation. The handler will be at the beginning of the file. We can move it for any location for reading and writing. W plus says that this is also for reading and writing, but if the file already exists, it is truncated, new data can be written, and once the data is written, we can read them back. Correct? We can write some data into the file. Those data we have written, that can be read. Those data can also be read. But if the data already there, it will be overwritten or truncated. And A plus is it opens the file in reading and writing. The file is created if it doesn't exist. The handler is positioned at the end of the file. The data is being written will be inserted at the end after the existing data. So data can be inserted at the end of the file. However, we can move the content anywhere in the file. We can move the content anywhere in the file for reading. Correct? Data can be automatically the handler will be at the end of the file. Correct? So looking into our requirement, a particular access board we will choose whether we will go for any one of these, whether we will go for reading, whether we will go for writing, append, R plus, W plus, or A plus. So while writing, subsequent we will be going writing some programs where these boards will be used over there. These modes will be used. Okay. So anyway, so next class I will tell you that how to open file and all this. And I said that I have not told you about this R. This R also I will tell in these slides and all. Let me take the attendance number 4, 5, 6. 15, roll number 15. Roll number 15.